Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today lecture is about the solution of non-linear coupled equation with the help of bvph2. This is the built-in code. We are on example number 4, and that example is open source example. You can download it. But what is their effects and how uh, you can run this example and how many time required to run this example, all of that things are questionable, and we are going to trying to answer all of these questions. And if we want to put over problems that's any problem which have four equations and four coupled equations, and we want to solve it with the help of bvph2. Let you can see here that is there is a two region of law. First one have two differential equations, both have are the second order differential equation, and region 2 also involve both are the second order differential equation. But we are talking here about that the equation number 22 and 23. You can see here the u1 depend on theta 1, and in the next one theta 1 is depend on u1. This is the kind of the coupled equation. And the region 2, in region 2 u2 is depend on theta 2, and into theta 2 depend on u2. You can easily see that there is no relation between u1 and theta 2 and theta 2 and theta 1, but there is a relation between u1 and theta 1. So it is a more general equation we are going to solve with the bvph2 code. Here is their subjects to their boundary conditions, that is u1 at 1 equal to 1 and u1 at 1 equal to 1, and that is the differential equation with boundary conditions. All our boundary conditions are given here, and you can see the boundary conditions are 2, 3, 4, 5, 6, 7 and 8 boundary condition. And here you can see there are two boundary condition involved for the first equation. 22 needs to solve two boundary condition, 23 also with 2, 24 2 and 25 2. Total equations are 4. We need 4 into 2 mean 8 boundary condition. All other conditions are given below. Here where you can see that some parameters are involved, that's it, gr, Reynolds number, and another parameter occurred in this number. Gr is the Grashof number, and ec is the Eckert number, Prandtl, pr Prandtl, and re is the Reynolds number, m is the Hartmann number, and p is the dimensionless pressure gradient. This model describe a fluid dynamically Poisson flow and heat transfer in include in a channel. Now we are going to solve it by the help of bvph2 to solve equation 22 to 29 directly without difficulty, since all parameters on the system will be given. We have number of equation 4 and type of equation 1. Here is the type of equation 1. First we write this the whole code in over Mathematica format. That is type equation 1. You know about the why we use the type equation 1, because all are the parameters have their values. If any one of the parameter that we don't know, in that case we write type equation equal to 2. Now the second one is the number of equations. There are 4 number of equations. We write all of these. This is the pattern to write down the all equation. First one is the f1 z underscore u1 s1 u2 and s2. There are 4 unknown all involved, that is the u1 u2 and s1 s2 and lambda. This is the first equation. We write it in this form. Second one equation we write this is You can see here all the format starting from small f, and we use the independent variable is here is y, but in that case we write in place of y we use the z. In uh, in this place you can see when we use the 1 2 3 4, that's mean to say this is the equation number, and z is the independent variable, and these four are the dependent variables. We want to know about all of these four variables and their graphical results. Okay, we put it in the Mathematica folder. And next one, now we are going to define the boundary conditions. The boundary conditions are a totally boundary condition are 8. And now we start from 1 to 8. Z is the independent variable and these are the dependent variable. We just mentioned BC in place of F. Remaining things are same in the left hand side as before, right here. Next one is to say the right hand side, that is the u1 at 1 equal to 1, u1 minus u2, uh, that's mean to say u1 equal to u2 at z equal to 0, u2 at minus 1 equal to 0, and first derivative of u1 minus first derivative of u2 multiply by lambda over h equal to 0 at point z equal to 0. Same thing is here, that is the s1 equal to 1 at point z approaches to 1, s1 minus s2 at the point z approaches to 0. Here we use the z approaches to 0 mean to say y approaches to 0. This is the global variable. We choose it in bvph as. Now we are here and write down all of our boundary conditions. The boundary condition number A, the derivative of s1 with respect to z minus derivative of s2 with respect to z into lambda of t over h, and at point z approaches to 0. All are the boundary conditions are written here. There are just two steps. First one is to write the differential equation. Second one, write the boundary condition. Now let's move on the third one. Now we let us input the solution interval. There is the solution interval, that is the 0 and 1. Here you for this one is the u1 and this is used for u2 and this one. You can see here the 1 is used for u1, 2 is used for u2 s1, 3 is used for u2, and 4 is used for s2. There are four unknown variables. Now let's we move on furthermore. We now all the value initial guesses we select. Note the solution interval are not the same. Since all the solution interval are the finite interval, we do not have specific integral interval to compute the square residual error. It is talking about that we don't mention any furthermore condition that you can see in our previous lecture. In that lecture we mentioned that in place of infinity we choose some value, but here is no infinity, so we don't need to choose any value for infinity. Next one is that we are here and choose the initial guesses. The initial guesses are u1 at 0 equal to lambda by h, z minus z square plus 1, theta 1 at 0 equal to this one, and u2 at this. These are the initial guesses. We are calculated it by a simple method. First of all, we choose a linear operator and calculate the initial guesses that satisfy. We choose all four initial guesses. We have freedom to choose the initial guesses. For this purpose, you can see a lecture or over a few lectures that talk about the choosing of initial guesses. This is the separate one lecture. Today we are on bvph2 method and their uses. Next one to move on this, the auxiliary linear operator are choose as. Now we choose the auxiliary linear operator. The auxiliary linear operator are the all of the second order, because all are the same. All u1 is involved second derivative, u s1, u2 and s2 all are mentioned here. Now note we have delayed sign. You know this is the called the delayed set delayed. This is used because define the linear operator and z is independent variable in the package. Here this operator is used for staff for calculation, and it is only remember the result not mentioned over screen. Next one, without loss of generality, let us consider the case when prompter is this one. There is the over given variables. We put all of the variables here, and after substitute these values of the constant. At this time we have input all the data for this problem except the convergence control parameter C naught of k. We minimize the square residual error for the fourth order approximation to obtain optimal values of C naught of k by the command this one. This is the command for calculating the basic value. That one is the convergence control parameter, and here we use the fourth because there is a four differential equation and all have a single one convergence control parameter. Now with the second parameter get optimal variables is empty list, which means that we give no constant on the convergence control parameter this. After some time we obtain the optimal values of C naught of k, which is this one, and then we will mean module bvph to get 30th order approximation. After simplification it is calculate all of the result and automatically put the convergence control parameters in above results and get the bvph1 to 30. The 30th order approximation of u1 theta 1 u2 theta 2 are stored in u130 230 330 and 430. You people should know about that what is meant by the 130 230. 130 mean to say when we write 130, it means this is the value of u1, this is the value of u2 s1, and this is the value of u2 and s2. This is there is the values, maybe this is u1 s1 u2 and s2. They all values are stored in this way. We can plot as we want respectively, while the corresponding square residual error tolerance 30, the 30th order approximation are plotted in figure 10. The value of theta y agrees with the results black dots as shown in the figure 10. The 30th order approximation theta y gives the heat transfer rate 8, and while the agree with this one, the total error of the system, here is a dots that satisfy the error that's, and this is over graphical result. But for getting the graphical result we have to choose, here is the plot command, and we get this result. This one is the example number 4, and we mention here if we have coupled nonlinear differential equations and how we smartly solve it by using the bvph2. Here is the code is running, but it is the time consuming to be very consuming. Here it is moving maybe from 2 hours, but it is going to be working when it is it have done. So I will show you how this result is. Again, this is the example 4. We mention all of these things, and here we write all of things that you see in the in our problem, that is mentioned here. This is the way. Now if you want to you are here bvph1 of this, the input is load. Here is the sum terms and the values are defined here. Now I'm starting from the governing equation. The first ODE is 5s1 and u double prime. Second ODE, the third ODE is this one, and fourth ODE is this one. After that, the boundary condition, there are 8 boundary conditions are given here. Or domain of the ODE is 0 to 1 and -1 to 0. There is a change in the domain of both the conditions. After that, integral interval of the error is this one. Convergence control parameter in ham is this one. This is the convergence control parameters. There are our initial guesses. After that, auxiliary linear operators. This is the auxiliary linear operator and auxiliary function. Here we choose auxiliary function is 1. Convergence control parameter is this one, and computing optimal values. This is going to be compute for the values of k 1, 2, 3, and 4. Here it is working for some time. It is to be very time consuming. For obtain the result, we have a possibility, that is to, if we use a 1 to 30 bvph 1 to 30 in place, we can write here 1 to 10. After that we write 11 to 15, and then 16 to 20. In that way we can calculate, but it also be time consuming, because the first maybe 10 step it is fastly give us the results, but there's extra values, extra commands, and should need to more complicated, and it is need some time. Okay, I am going to show you what happened here and how many memory of the system is in use, and which there are 4 kernel are working, all are running. Now I am going here and show you what happened. If I am going to click on our keyboard and show that how many memory of the system is running, that is control alt and this is the task manager. You can see here, this is the Mathematica file. We want detail. Here you can see that Mathematica 11.39, and they use the 69% of the memory of the and it is used CPU 56%. CPU overall 56%, in which the Mathematica is using 29 point. There are a lot of things are running here, but the role of the Mathematica is you can see here 28.5%, and this is the 3700 3800 something MB memory is used. You can I have the RAM capacity is 18 GB, so this 8 GB, that is it is used now maybe equal to 4 GB, and it's still working. You people need to the highest RAM capacity for calculation and using for this purpose. It is very okay. I'm going to, maybe this is 3855 MB it is used, and still it is moving forward very fastly. It is about 3.8 GB. 3.8 GB is used, and total RAM size is 8 GB. It is going to be 4000 above. It is complete in that case when if the result is within the 8 GB. Okay, this is the result. If you people want to calculate, you should have to know their results, and you need to a powerful computer for the calculation. It is very simple, and this function involving the sine function, you can see here in equation sine function due to y. In that case, where is a sine function or another type of a function, in that case we use the command type base and the hybrid. After that the float and all of these things. Maybe these kind of things are discussed in the previous lecture, in our previous lecture, but you can see here the output, there is a no result is shown of sine, cos or any other thing, because it is the simplified form, and this is the output form. There are all outputs. You can see here it is go down the value 300 3000, because sometime when we calculate any one step, the values is increase, and finally when the step is complete, the memory is going to be down, and this is the approach. There is, it is going to maximum maybe 4 GB approximately. This method may be used. Minimum of memory maybe 5 GB of your system for running this code, 5 GB. But here it is still working. Maybe it is so time consuming. I am started from 2 hours before, but this is the example number 4. Thank you very much.